In this lesson, I'm going to be talking about antiderivatives and indefinite integration. So what we're going to be looking at here is I'm going to be giving you now the derivative, and you need to be coming up with what the original function is. So what function's derivative could be this? Well, one of the functions could be x to the third. One of my functions could be x to the third plus 7, because the derivative of this is still 3x squared. One of my functions could be minus 83. One of my functions could be x to the third plus 487, my favorite number. Remind me to tell you in class why that's my favorite number. So in general, we have some constant c that when we take the antiderivative of a function, we have to add in a constant c. So a function big F is called the antiderivative of a function small f on the given interval if the derivative of f equals f of x for all x. Okay, so we know that here, this is our notation for the derivative. Now we have this little symbol means integral, and we're going to talk more about that symbol over the next few days. But the antiderivative, or the integral of f of x dx, is big F of x plus c. So here, the antiderivative, or the integral of x squared dx, is going to be 1/3 x to the third plus some constant c. Okay, and this is going back to the previous example. I actually adjusted the example on the previous screen for this video, but you get the idea here. Okay, some examples. So our general rule here. Okay, so make sure you have this general rule in your notes. This is a really good general rule. So the antiderivative, or the integral of x to the r dx, okay, you add 1 to the exponent, 1 over your new exponent plus c. And then r cannot equal 1. And we'll talk about that example here in a minute. So evaluate each indefinite integral. So I have add 1 to my exponent, 1 over my new exponent plus c. I typically would write anything that was a fraction with a negative exponent. Trust me, that's going to help you out. So add 1 to your exponent, 1 over your new exponent plus c. Any radicals, I would recommend that you write those so that your exponents are in fraction form. So I add 1 to my exponent, 1 over my new exponent, take the reciprocal of that, plus c. So some properties now of integrals. And we're going to be building our properties of integrals. You can pull a constant out in front, very much like the derivative. And we can take the antiderivative of, if you have a polynomial, you can just take the antiderivative of each one of these terms. So if I'm taking the antiderivative of each one of the terms, I don't need my integral symbol anymore. So the antiderivative of this term, I don't know what's going on here. I apologize. That's really annoying. Anyway, moving along. I'm not going to redo this video. I apologize. Add 1 to your new exponent, 1 over your new exponent. Add 1 to your exponent, 1 over your new exponent. And then don't forget your plus c. Trigonometric integrals. So I would take a minute, stop the video, write these trig integrals down. Things you need to remember, that you do have some. They're going to be negative. Okay, make sure you're taking note of those. Okay, and you kind of have to be really careful on those. I often take a step back and think, oh, did I do this right? Okay, and remember that you can always take the derivative. So even going here, I could take the derivative of this function. So I should go back here and take the derivative of this, bring down my exponent, reduce by 1, bring down the exponent, reduce by 1. I get that answer right there. I didn't even think of that till just now. Okay, so a little bit more work here. Okay, sometimes you're going to have to manipulate. So I'm going to write this as cosine of x over sine of x times by 1 over sine of x dx. Cosine over sine is cotangent times by cosecant dx. Taking the antiderivative of that is negative cosecant x plus c. This one, there's no rules for when, well, there are rules for multiplying. There's no rules for dividing when we're in integrals. Okay, and I'm actually not even going to teach you guys the rule for when you're multiplying two functions and you have to take the integral. So this function here, okay, again, we have to manipulate it. I can't just take the integral of the top, the integral of the bottom. What I need to do is I need to manipulate this. So I'm going to manipulate this into splitting the numerator up. And then I'm going to manipulate it even more, and I'm going to write with negative exponents. Okay, add 1 to your exponent. That is t to the negative 1, 1 over your new next exponent. Plus, really, now you need to add in a t. I don't know why I'm thinking about that dt, because I didn't really explain to you guys what that dt is. Plus c. Okay, this is technically in a later section, and I debated taking this out, but I'm going to keep it in there. I kind of liked it, because if I expose you to these now, I don't know why that's doing that again. I can show you guys some more integrals, and you'll be used to them when we do them in a later video. 3 to the x dx. Okay, so the integral of this is 3 to the x over ln of my base plus c. Again, remember, I can take the derivative of this, and I should get that. Antiderivative of this, okay? Remember the derivative, I love e to the x. The derivative of e to the x is e to the x. So when I take the integral of e to the x, it's e to the x. Don't forget your plus c. And then the ln of x, okay, the integral of 1 over x is the ln of x, and you need some absolute value signs in there, plus c. Okay. All right. Now we're going to find the function whose graph passes through P. So I give you the derivative, and we now need to come up with the original function. So what I do is I find the antiderivative, or what function's derivative is cosine? Well, that's sine of x plus c. Now here I have an x, and I have an f of x. So I have 2 equals the sine of 0 plus c. Sine of 0 is 0. So I now have my function. Now I give you the second derivative. So to get to my first derivative, I take the antiderivative of this right side, add 1 to my exponent, 1 over my new exponent. Okay, and now I plug in. I use this piece here because this is 5 equals 3 minus 12 plus c. I get c to equal 14. I just plugged in 1 for x. So I now have my f of x function, I'm sorry, my f prime of x function. And I then take my antiderivative to get my f of x function, which is antiderivative. I was thinking take the derivative. Ooh, it's going to take you a while to get used to this. I often struggle with this. Oh, I didn't plug in my c. My c is actually 14. I often struggle with integrals. It takes a while for my brain to adjust. Okay, so now I have this piece. F of 2 is negative 3. So negative 3 is equal to and if I solve for c there, I get 15. So my final function, f of x, is x to the third. It's actually negative 15. X to the third minus 6x squared plus 14x minus 15. And one last example for us. We can also do this with particle motion. Acceleration. How do I get from acceleration back to velocity? I take the antiderivative. I plug in negative 3, 0, because x is 0, or I'm sorry, t is 0. Those both go to 0, so my c is that. So I have my velocity function now. I take the antiderivative of velocity to get me back to position. Again, I plug in 0 for t and 12 for s of t. So that's 12. That goes to 0. That goes to 0. That goes to 0. So that's c. So now I now have my position function. And that is all I have for you. Oh, that's interesting. We'll see how loud this is.